the beautiful clouds on the space. Nebulae. Hello everyone, this is AWZ. Welcome to our channel. Don't forget to subscribe. Enjoy. What are nebulae and where do they come from? A nebula is a truly amazing sight to behold. Nebulae, named after the Latin word for cloud, are not just vast clouds of dust, hydrogen and helium gas, and plasma. They are also frequently stellar nurseries, or locations where stars are created. For centuries, distant galaxies were frequently misidentified as these huge clouds. The name nebula was originally applied to any scattered astronomical object, including galaxies beyond the Milky Way. Before Vesto Slipher, Edwin Hubble, and others revealed the real nature of galaxies in the early 20th century, the Andromeda Galaxy was referred to as the Andromeda Nebula, and spiral galaxies in general as spiral nebulae. Unfortunately, such statements only scrape the surface of what nebulae are and what they mean. Nebulae have supplied humanity with limitless fascination and discovery due to their development process, role in star and planetary formation, and diversity. Scientists and astronomers have known for some time that outer space is not a complete vacuum. In actuality, it is composed of gas and dust particles known as the interstellar medium, ISM. Approximately 99% of the ISM is made up of gas, with hydrogen accounting for 75% of its mass and helium accounting for the remaining 25%. The interstellar gas is made up of both neutral atoms and molecules and charged particles, also known as plasma, such as ions and electrons. With an average density of around 1 atom per cubic centimeter, this gas is exceedingly dilute. At sea level, the density of the Earth's atmosphere is roughly 30 quintillion molecules per cubic centimeter, 3.0 by 1019 per cm3. Despite the fact that interstellar gas is widely spread, the amount of stuff accumulates throughout the enormous distances between stars. With enough gravitational force between clouds, these materials can eventually combine and collapse to form stars and planetary systems. Formation of a nebula. A nebula is generated when sections of the interstellar medium collapse due to gravitational collapse. Matter clumps together due to mutual gravitational pull, generating zones of increasing density. Stars may emerge at the center of the falling material as a result of this, and their ultraviolet ionizing radiation causes the surrounding gas to become visible at optical wavelengths. Most nebulae are enormous in size, stretching hundreds of light years across. Although denser than the surrounding space, most nebulae are significantly less dense than any vacuum formed on Earth. In fact, a nebular cloud the size of Earth would contain so little material that its mass would be only a few kilos. Classification of nebulae. There are 4 types of stellar objects that can be called nebulae. Most are diffuse nebulae, which implies they have no clearly defined borders. These are further classified into 2 types based on their behavior with visible light: emission nebulae and reflection nebulae. Emission nebulae are nebulae that emit spectral line radiation from ionized gas and are commonly referred to as HII areas since they are mostly made up of ionized hydrogen. Reflection nebulae, on the other hand, do not emit much visible light but are nonetheless bright because they reflect light from neighboring stars. Dark nebulae are opaque clouds that do not emit visible radiation and are not lighted by stars, but instead obscure light from illuminating objects behind them. Dark nebulae, like emission and reflection nebulae, emit infrared light, owing to the existence of dust within them. Some nebulae are produced by supernova explosions and are so categorized as supernova remnant nebulae. In this instance, short-lived stars undergo core implosion and have their outer layers blown off. This explosion leaves a remnant in the form of a compact object, a neutron star, and a cloud of gas and dust that has been ionized by the explosion's energy. Other nebulae may form as planetary nebulae, which are formed when a low-mass star reaches the end of its existence. Stars undergo their red giant phase in this scenario, gradually shedding their outer layers due to helium flashes in their center. When a star loses enough material, its temperature rises and the UV radiation it emits ionizes the surrounding material. This class also includes the protoplanetary nebulae, PPN, subclass, which refers to astronomical objects that are through a brief phase in the evolution of a star. This is the fast phase that occurs between the late asymptotic giant branch, LAGB, and the subsequent planetary nebula, PN. The star loses mass during the asymptotic giant branch, AGB, phase, generating a circumstellar shell of hydrogen gas. When this phase ends, the star enters the PPN phase, when it is fueled by a central star and emits strong infrared radiation, causing it to become a reflection nebula. The PPN phase lasts until the core star reaches 30,000 K, at which point it is hot enough to ionize the surrounding gas. Nebula observation history. During classical antiquity and the Middle Ages, astronomers observed numerous hazy objects in the night sky. Ptolemy made the earliest recorded sighting in 150 CE, when he reported the presence of 5 stars in Almagest that seemed hazy in his book. He also noticed a bright zone between the constellations Ursa Major and Leo that was not related with any visible star. The earliest observation of a nebula was made by Persian astronomer Abd al-Rahman al-Sufi in his Book of Fixed Stars, written in 964 CE. According to Al-Observations, Sufi's a small cloud was seen in the night sky near where the Andromeda Galaxy is currently known to be. Other nebulous objects cataloged by him include the Omicron Velorum and Brachis cluster. The supernova that formed the Crab Nebula, SN 1054, was seen to scientists on Earth on July 4, 1054, and recorded observations made by both Arabic and Chinese astronomers have been identified. While there is anecdotal evidence that other civilizations witnessed the supernova, no records have been discovered. By the 17th century, advances in telescope technology had resulted in the first confirmed observations of nebulae. The earliest known observation of the Orion Nebula was made in 1610 by French astronomer Nicolas Claude Fabry de Peiresc. Johann Baptist Cécit, a Swiss astronomer, discovered the nebula in 1618, and Christian Huygens undertook the first detailed study of it in 1659. The number of observed nebulae began to expand during the 18th century, and astronomers began to establish catalogs. In his An Account of Various Nebulae or Lucid Spots Like Clouds, lately discovered amid the fixed stars by help of the telescope, Edmund Halley published a list of 6 nebulae M11, M13, M22, M31, M42, and the Omega Centauri globular cluster, NGC 5139, in 1715. In 1746, French astronomer Jean-Philippe de Chasseaux created a list of 20 nebulae, including 8 previously unknown nebulae. Nicolas Louis de Lacaille catalogued 42 nebulae from the Cape of Good Hope between 1751 and 1753, the majority of which were previously unknown. In 1781, Charles Messier published his inventory of 103 nebulae, now known as Messier objects, some of which were galaxies and comets. Thanks to the work of William Herschel and his sister, Caroline, the number of observed and catalogued nebulae has substantially increased. The two published their catalog of 1,000 new nebulae and clusters of stars in 1786, which was followed by a second and third catalog in 1786 and 1802. Herschel thought these nebulae were just unresolved groups of stars at the time, but that changed in 1790 when he discovered a real nebula orbiting a distant star. Beginning in 1864, English astronomer William Huggins began to distinguish nebulae by their spectra. Approximately one-third of them exhibited a gas emission spectrum, i.e. emission nebulae, whereas the rest had a continuous spectrum compatible with a star mass, i.e. planetary nebulae. After seeing how a nebula orbiting a star mirrored the spectra of the Pleiades open cluster, American astronomer Vesto Slipher introduced the subcategory of reflection nebulae in 1912. Many previously detected nebulae were in fact distant spiral galaxies by 1922, as part of the great debate regarding the nature of spiral nebulae and the scale of the universe. That same year, Edwin Hubble stated that nearly all nebulae are related with stars and are illuminated by starlight. Since then, the number of real nebulae, as opposed to star clusters and distant galaxies, has increased significantly, and their classification has been revised thanks to advances in observational and spectroscopic equipment. In short, nebulae are not just the beginnings of stellar evolution, but they can also be the end. And, among all the star systems that make up our galaxy and cosmos, there are bound to be nebulous clouds and masses ready to give birth to the next generation of stars. This is all for now. Check out other videos on our channel. Enjoy!